Sloping. Slope. I like to call it sloping just because it's more fun, but we're going over slope now. Slope is also called the rate of change. The rate of change is the ratio that compares the amount of change in a dependent variable to the amount of change in an independent variable. Now, notice I said ratio. Ratio is a fraction. So the rate of change in the dependent variable, so that means dependent goes on top and independent goes on the bottom. Okay? So we're comparing two numbers, the dependent to the independent. Now, dependent is also known as y, and the independent is also known as x. So, how do I measure change? Usually you measure change by subtraction. Kind of like this. What's the difference between 5 and 2? How much did it change? How much did it change? It changed by 3. That's how you measure change. Now here's a tricky part. You have to make sure you get in the right order. So if I say 5 went to 10, how would you figure that out? What's the amount of change? You wouldn't do 5 minus 10 because that would give you a negative change. And this is obviously a positive change. You would have to do 10 minus 5. The second value minus the first value. Even if it's negative, if we went from 5 to 2, that's a negative change. It got smaller. So you do 2 minus 5, which is negative 3. The change is negative 3. And that's how you measure change. You measure it by subtraction. So we subtract to measure change. Now, here we have rate of change is equal to the change in the y, you see how I subtracted it, over the change in x, that's I subtracted it. Now remember what I just said. We do the second value minus the first value. So when we're talking about y's, different y values, we have to put a label on them. So we always do the second minus the first. The second minus the first. This is also called the slope formula. Rate of change is the same thing as slope. Alright, components of slope. Where does y2 and y1 come from? What is x2, x1? Well, what we're talking about is on a graph, an ordered pair. So one ordered pair would be the first x value, comma, and the first y value. The other ordered pair would be the second x value and the second y value. They're ordered pairs on a graph. So if you wanted to figure out the slope or the change between the two ordered pairs, this is what you would do. You would subtract the top minus the bottom, the dependent minus the independent. Now, slope is also called something else, or we refer to it as something else. We also refer to it as rise over run. And the reason why is because y goes up and down. A change in it would make it go up and down. Remember translations? How when we changed it as shape going up or down, we subtracted it from the y value. So rate of change here would be rise, because things that change on the y is rise. And things that change on the x would be a run, because it goes side to side. So rise is the change in y, run is the change in x. Alright, here's an example. Here's a line graph that has 2 points highlighted on it, and we want to know the slope between the two. What's the change between them? How far did it rise over how far did it run? Now, there's one easy way of doing this. You can just count. How far did it rise? 1, 2, 3, 4, 5, 6. Over how far it ran? 1, 2, 3. Now, Mr. Naval messed up because this is backwards. Sorry. There we go. I don't know why I did that. Dyslexia, I guess. All right, so 6 over 3. Now, when we reduce that, we get 2. 2 is our slope. It's a reduced form of our slope. The rise is 2, the run is 3. And you're thinking, hey, Mr. Naval, you didn't rise 2 and go over 1 to get to from this point to this point. Well, slope is constant on linear functions. So, look, I go up 2, 1, 1, 2, and over 1, and I hit my graph. If I keep doing this, I will eventually get to this point. See, watch. Up 2 over 1. Up 2 over 1. So you see how it's a reduced form of slope? It's a reduced form of my rise and my run to get from one point to the other point. Now, the other way of figuring this out would actually be using the formula. Let me change this again. Rise is the change in y. Remember y2 minus y1 over x2 minus x1? So what is my second y value on these 2 points? Well, here's my y values. So this would be my second one going from left to right. So I'm going to rewrite this. 6 is my second y value, and my first y value is 0. Divided by my second x value minus my first x value. 6 minus 0 is 6. 3 minus 0 is 3. Reduce it and you get 2. Which is the same thing we had earlier. They're both the same thing. Same idea, same concept. One you're actually subtracting. The other one you're just counting. You're finding the difference between the 2 points. Now, this would be a good way if you were just given points. Counting would be a good way if you were given a graph like this one. Here's 2 examples. Now, some of y'all would already start counting. Up 1, up 2. The only problem is these don't count as regular points because you see how it goes up 500 at a time. So the best way to do this one would be to use the formula, the rate of change, the change in y. So what are my y values? What's the second one? So 2,000 minus 3,000 over my second x, 60, minus my first x, 20. $2,000 minus 3,000 is negative 1,000. $60 minus 20 is 40. All right, now we got to reduce this. I can cross out my zeros, and 4 goes into 100 25 times. So my slope for this is negative 25. It's a negative trend because it goes down from left to right, and its slope is 25 over 1. And that's it. That's all there is to it. There's my slope. Let's try this one. Second y value, 24, minus first y value, 12, divided by second x value, 4, minus first x value, 2. 24 minus 12 is 12. 4 minus 2 is 2. Reduce it, and you end up getting 6 as your slope. In fact, we can actually measure this. 6 is my slope. That means I can start here, go up 6 over 1, hit the graph. Up 6 over 1, up 6 over 1, up 6 over 1, up 6 over 1. And I keep hitting my graph. So that's slope. That's another way you can actually check it. All right, here's a table. We're trying to find the slope just given a table. Well, you can use any ordered pair you want, as long as you pick 2. So let's say I'm using this one and this one. Okay, so those are the 2 ordered pairs I picked. So my y2 minus y1, my second y value would be -3 minus -1. My second x value would be 4 minus 2. So -3 minus -1. When you have minus and negative, it becomes a positive. So -3 plus 1 would be -2. 4 minus 2 would be 2. And when we reduce that, it ends up reducing to -1. And that's my slope given a table. That's all you have to do. Now, here's 2 tricky ones. Let's pick 2 points on these graphs. Let's pick this one. And let's say this one. Doesn't matter, you could pick different ones. Alright, here's 2 points. Now, I'm just picking these at random. Keep that in mind. So let's see. We're just going to find the slope of the green one first. So, what point is this? Let's see, that goes 1, 2, 3, 4, 5, 6. For both of them for the x values. And the y value for this bottom one would be 1. And the y value for the top one would be 1, 2, 3, 5, 6, 7, 8. Now, you have to figure out the change in y over the change in x. So take my second x value. Oh my gosh. Which one's the second one? Well, you could pick. Let's say 1's the second one. So 1 minus 8. And then the change in the y. Oh, I did that backwards. No, I didn't. Change in y first, which is 1 minus 8. And then the change in x, which would be 6 minus 6. What happens? You end up getting -7 over 0. Can you divide by 0? You cannot divide by 0. You just can't. If you could, it would change math as we know it. So you cannot divide by 0, so this particular function, a vertical line, cannot have a slope. And in fact, alright guys, so I have 2 points that I've picked. 6, 8, 6, 1. Now those are picked at random, so let's find the slope. Let's see, the second x value. Well, we don't know which one of these is second, so pick one. Let's say this one is the second value. So y2 minus y1 over x2 minus x1. And this is kind of goes with the fact that we had to choose which one was second. You should already kind of throw up a red flag in your mind Why would we have to choose? I'm kind of confused. It's because of this. When we actually solve this out, what do we get on the bottom? We get a 0. And so you can't divide by 0. So this slope doesn't exist. It doesn't exist at all. So if you remember when we talked about functions, a vertical line is considered not a function because this x value has more than one y value. So a vertical line doesn't even have a slope. It's vertical. Now, this is the weird part. What about a horizontal line? It passes the vertical line test, so it has a slope. Here, let me erase all this stuff. There we go. Let's find the slope on this one. Let's pick two random dots. How about right here? And how about right here? This dot is 2, 4. And this dot is 2, 3, 4, 5. It's negative 6, 4. Now let's find the slope of it. Rise over run, so the change in y, so 4 minus 4, over the change in x. Now it's easy. This is my second x value. This is my first x value. So 2 minus negative 6. We get 0 on top, divided by, this turns to a positive, so 2 plus 6 is 8. Which doesn't matter because 0 divided by any number is 0. So a vertical line has no slope, where a horizontal line has 0 slope. It's kind of weird, huh? Those are the two ones that give most people trouble. And that's it, folks. So I hope you come back next week and you're ready to learn.